Hello and welcome to a new video. In this long-awaited video, which I couldn't produce because I was studying for my exams at school, I'll show you how you can make a GLFW window with OpenGL and ImGui for rendering. This video will cover the most basic way to actually do this, and this video serves as a Kickstarter for people who want to start making their own desktop applications, their own menus, for example, for cheats, for mods, for stuff like that, and actually start working with UI using C++. So let's get into it. First, we will have to go to these three websites. We will have to download GLFW and GLAD. I'll explain what these are in a second. First, I will just guide you through the setup. First, on this website, you go to Windows precompiled binaries, and I will download the 64-bit Windows binaries because I'm using a 64-bit and I'm working with 64-bit, so this is what I'm going to use. Alright, and for GLAD, choose the profile core, version 3.3, OpenGL, C++, and press on generate and download it. I won't download them because I already have them in front of my desktop. Next, I will go to the ImGui GitHub, go to the releases, scroll down and download the source. Now let's actually get started in the setup. We will create a new Visual Studio project, which will be empty as always. We press on this button to show all the files instead of these filters. We will go then to our repos folder, go to our folder over here, project folder, create a new folder, call it library, create another new folder called ImGui. Inside the library we need to create two folders, one called lib, another one called include. Now the reason why we're doing this and why these folders are inside here is just for simplicity. What we're doing right here is that we will set up our project so that it can include and work with the GLFW library and the GLAD library so that we can load OpenGL. Before we actually get into this video and tutorial, I need you to update immediately your graphic drivers, no matter if you're using AMD or NVIDIA. Now, why do you need to do that? Well, once you download an update for your graphics driver, it also includes the newest OpenGL API version. So enough annoying specifications, and let's actually get into the setting up part. We'll go to our library and open the GLFW zip, which you downloaded from the previous website that I showed you in the beginning of this video. You will then go to include, take this folder and grab it and extract inside the include folder inside your repositories library folder, which we just created. We then select the version of Visual Studio that we're using. In this case, we're using Visual Studio 2022. We will go and we will take glfw3.lib and put it inside our lib folder. Really nice. Next, we will close this, go to GLAD, go to include, grab these two, put them inside include. Next, go to source, go back, and right inside at your files where your repository or your repository project folder, you just grab and drop glad.c. Next, you go to ImGui. You open ImGui folder inside your repo project folder and you select all these files. We put everything except for these get noise, get attributes, whatever, and the shit and the license. We don't need those. Only the main files. We will then go to backends and we will grab the ImGui implementation for OpenGL so that it can actually work with our Visual Studio project. Alright. Next, we need to grab the two GLFW files as well, put them inside the ImGui, and we're almost finished. Now we go back to our project. We will press on this refresh button, the ImGui folder, right click on it, and press include in project. we will do the same for glad.c. Now we will have to go to our properties, select all platforms or configurations. We will select the language standard to the latest version. We will go to our linker input, edit, and here we will write glfw free.lib and OpenGL32.lib so that we link these two lib files in our project so that we can actually use their functionalities. Alright. Next we go to the C++ directories. We will go to include directories, edit, press on this little folder icon, press on those little three dots. You go to library, include, press OK. Then you go to library directories, do once again, little folder icon, three dots, go to lib, select the folder, press OK, apply, and we are ready to roll. In order to know if we set up correctly, we will create our main C++ source file, create our program over here, our entry point, and now we will include the necessary files so we see if we actually include them and it works if we include them in this file. Have input and output so that we can actually check right now if we have any errors with the setup. So if it works and it compiles, this output string should be outputted to the console and we should see it. So it's compiling and it works. Really nice, no problems whatsoever. So now we can actually start. Before we actually start, I want to explain a little bit what OpenGL, ImGui, Glfw, and GLAD is. So OpenGL is a low-level graphics API that allows software to interact with a computer's graphics card to render 2D and 3D graphics. It's also cross-platform, so this is why I prefer it compared to DirectX 11. Also, I find it a little bit more easier. ImGui. ImGui is a high-level GUI library which is built on top OpenGL or other rendering backends like DirectX. This simplifies creating GUI elements like buttons, sliders, and windows within applications by automating many things. It's really useful, especially when creating menus for sheets or even desktop applications sometimes in C++. It's really efficient. Alright, next I want to talk about what GLFW is. I've been saying this word for a while since we started this video, and probably you don't even know what this is. So GLFW simplifies window and input management. What does that mean? Well, remember what we were doing with ESP at the ESP video when we were, for example, creating the window, having to register the class, all that crap? Well, GLFW automates that, makes it really, really simple. So key handling, window creations, inputs, etc. is all done much more easier with GLFW. And GLFW goes really, really well with OpenGL. Now, as I told you before, the OpenGL API is already installed usually with your graphics driver, depending on what operating system you have and blah blah blah. But to actually load OpenGL in a project like this, we need to use something like GLAD. Well, GLAD facilitates loading OpenGL functions dynamically at runtime. Since we can't directly include OpenGL in our project, we need to use something like GLAD to load its functions and to be able to work with OpenGL. So that's what GLAD does. It also ensures compatibility and flexibility across operating systems, which is really nice. So let's actually start. We will delete this, whatever, and I will write a few functions, and then I will explain them after I read them, since it's more practical with me. Alrighty, so let's actually explain this function over here and what it really does. Now, the glf window hint function in glfw is used to set specific configuration options or hints creation of a window and its OpenGL context, like certain preferences or settings for how the window should behave or how its OpenGL context should be initialized. Basically, it basically configures the setting for a future window creation. So when a window is created, it will exhibit these configurations over here. It's also, as I said, really important for OpenGL because we need to set window hints to tell GLFW what version of OpenGL we're using. So GLFW context version major, it's the major version of OpenGL, which is free in this case. We're using 3.3, so free, and the 0.3 is this, because it's minor. It's logical. Now this one, we're setting the GLF OpenGL profile for the window to core profile. What does that mean? Well, first we need to look at the OpenGL profile. An OpenGL profile is like a package of functions. Two well-known profiles are core, which consists of modern functions, and compatibility, modern and outdated functions. But you probably noticed when we downloaded GLAD, we specified for OpenGL core, because in this video we'll be using modern OpenGL. Next, these two ones are really interesting because I know that many of you are watching this video since it's really useful for making menus, especially for cheats and overlays. So these two ones help with that. It makes the future window, the future created window, transparent and removes decorations. Decorations are these that white bar you see on top of windows and stuff with the minimize, maximize, and close button. But we will not use this for now because I want to show you the basics and explain the main functions to you. Now we will need to create a window. Alright, now you might look at this and you might get a little bit confused. Now that is alright, I'll explain it to you. What many of you might get confused by is this. What is this? What is this data type? Why is it a pointer? Why is the window a pointer to this data type? Now this data type is a structure defined in the glfw library. It encapsulates all information and functionalities related to a window created using glfw. So this indicates properties like window, size, position, callback events, key presses or mouse movements, blah blah blah. It's a pointer because it's more efficient. It allocates memory dynamically. glfw provides many functions that operate on glfw window pointer types, meaning that many functions, when we have to work with a window many times and we need to input a window as an argument, glfw will ask us to specifically give a pointer to our window. So by doing this, we're basically making that a little bit more automated because we don't have to complicate it a little bit more code. You can just do it like this. It's easier. Let's explain the arguments. So with height, self-explanatory, I put it as my resolution. Name of the window. If this should be full screen or not. Null, it means that it's going to be windowed. This is window sharing. It's really bullshit. Just put it to null. It's really, really bad. Okay, next we will do a little bit of error checking. Also, we will properly destroy our window for good measure and because it's a good practice to do that. Alright, so now we will have to make our window the current context. I'll explain what that is in a second. So an OpenGL context encapsulates everything needed to render graphics on a specific window or surface. This function specifies that all subsequent OpenGL commands will affect this specific window, which we put, and it's our window. Alright, next. Glad load GL. What is this? Well, this is exactly what I explained earlier. We need glad to load our OpenGL functions dynamically. Well, this is the function that basically does it. Alright, so with this function you will be able to use OpenGL functions and configure it for your preferred version. Next, our viewport. So our viewport is basically the area of the window we want OpenGL to render on. Now this is the X and Y. X coordinate of the, I think it's the bottom left corner of the window, and I think this is the Y coordinate of the bottom left corner. And the width and the height, when you specify width and height, it will extend on from that point. And because we set it to the resolution which our window is, it will make it and cover all the surface, the viewport will cover all the surface of our window. Now we can create our main while loop. This while loop will repeat its code block when our window shouldn't close. So when a window is open and will not close, then it just our main loop will run. Inside the main loop, we need a few important things. Alright, so let's first explain this. In a typical OpenGL setup, we need to clear our color buffer. Now, why is that? So this operation is typically performed at the beginning of rendering of a new frame. It ensures that the previous frame's contents do not interfere with the new frame. So it's clearing the color buffer, and this is what the color buffer is called, the color buffer bit. Now, we also need to swap buffers and polygons, but what's interesting about when we clear the color buffer is that we can actually set it at a value of the whole color buffer of our window. To do that, color, it's clear color, yeah, GL clear color, and here we can set some values. It doesn't really matter at all. Some float values and alpha, but these are color values. So what does this do? This function specifies the preset values. So the preset values are the values that are set in this case to the color buffer when the color buffer is cleared. And when the color buffer is cleared, then these values will be set to the color buffer, basically changing the window's color. So, and also keep in mind, OpenGL is a color format, is a little bit different. I actually forgot how it's called, it's unfortunate, but values for RGB range from 0 float to 1 float maximum. And also, now let's explain GLFW swap buffers of window. This is also self-explanatory. It swaps the buffers of the window, but what is that? So first we need to understand what the front and back buffer is. The front buffer is the frame that is currently being shown on a window. The back buffer is the frame which is being drawn on. It's basically where the next frame is being drawn on, the back buffer. Now when you switch the buffers, to be able to see changes on your screen. So the back buffer becomes the front buffer showing the new frame, and the new buffer becomes the back buffer, which gets drawn on, and they switch continuously. We need double buffering like this because it ensures that your rendering is smooth and does not flicker. Also, GLFW poll events. This is really interesting. because now GLFW here handles all our window events. What we were doing with Windows API to do them separately, and we couldn't even handle all the events, which could have been kind of cool to handle them. GLFW does it automatically, and it's really easy to use. We put it just here. Alright, now we're not done yet because we want to make this program run perfectly, smoothly, run correctly. So we first, boom. Now if we start this program, which is what, 60 lines of code with a ton of unnecessary spacing, that's really small. You will have a window and it will be like an orangey reddish color, and you see you can resize it. You have everything. It's really nice. Now this window is kind of useless and kind of bland, so we will use ImGui to render stuff automatically using OpenGL. We will initialize ImGui right here. Alright, so let's explain this ImGui initializing each function and what it does. So ImGui check version. Now this function checks the version of ImGui we are using. If it matches to the version of this application is compiled with, it basically ensures compatibility and prevention from potential issues of misusing a different version. Next, create context. Now, creating an ImGui context will initialize the use of the ImGui library, having all the configurations needed. This is really important for it to function. The context is required to manage all the ImGui state, settings, style, etc. basically. The I/O over here gets a reference to the I/O structure, which contains settings, input and output data from the ImGui. We need it for configurations of style, setting, input or output data for ImGui. Now this little thing, void I/O here, is actually optional. It's only a prevention from getting a warning from the compiler. So you can just get it off, it doesn't really matter, but it's good practice. ImGui style colors dark. This changes the ImGui default style to a dark style. ImGui implement GLFW initialize for OpenGL. This initializes the ImGui to be used with GLFW and OpenGL. This also gives ImGui the window that it will work with. This also sets up necessary bindings so that ImGui can work with GLFW and OpenGL. ImGui implement OpenGL free initialize, and then we put the version of OpenGL. Now this initializes ImGui to be used for OpenGL version 3.3. This sets up ImGui's rendering system to work with the specified version of ImGui, basically of OpenGL. It basically configurates the ImGui configurates settings based on the version of OpenGL. So this is the initialization. Now, to actually, here we have to go here in our main loop, and we will have to create new frames. I'll explain why we'll need this in a second. So the reason why ImGui is creating all these frames using OpenGL free, GLFW, and ImGui by itself is to prepare ImGui to handle input and render the GUI correctly using GLFW and OpenGL. Now, these functions I'll explain them in a second as well. They're really easy to understand. Inside these, I guess, two margins, you can, in a nutshell, call them. It's what should ImGui draw, render. It's all, by the way, it's always after OpenGL rendering. So if you have like a rendering of a primitive, like a triangle up here, not like inside your program, you put this so that it renders after OpenGL renders. Alright, so now inside here we can add something like text, and we can say, hi, this is nice and easy. I don't know, whatever. Next we have to call this function over here, ImGui render. You might think that this renders, but it doesn't really. So this completes the ImGui frame after you give it what you want to draw, which is in here. Data from above for rendering. So this basically prepares the draw data for rendering. It doesn't actually render it. To make it render, you have to do this. So now this function here, what it does, it uses OpenGL to render the draw data, which was prepared by this function, and this is the draw data, by the way. And in order to get the draw data, we just we need to put as argument the draw data, and to do that we have a function that does that for you. So it's really, really simple to understand. In order to terminate the program correctly, we need to shut down ImGui. So the implementation of ImGui with glfw shut down. Same with OpenGL and itself. Destroy context. Alright. I think it's better if we terminate OpenGL before we actually terminate glfw. Hey, looking back at my code, I realized one little thing. Is that this function, I'm not calling this function, I'm just writing it. So it doesn't really end, meaning that it just gets an error. And now when I do it, it works. See, I can collapse it, it works, I can hover it around. It's a really nice ImGui window. Really easy to make as well. Now we can close this. So by the way, this white thing, this is basically the decoration. We can also remove that if you want. So let's actually, if you want, there's many things you can add. There's, let's create a bool on top here. Let's call it active, and let's set it to true. And now we can make a checkbox. We can say something like this, say, I don't know, sp, for example. And then put the address of active. And we're going to get a checkbox. Now let's say you want to draw a line. So how do you do that actually? Well, it's pretty simple. We need to get a draw list. So it's an image draw list. It's a pointer draw score list equals GUI get. And now you have two options. It's either background draw list, which will refer to the ImGui window, the window menu, or the foreground draw list, which is what I think is the interesting one, because now it's talking about your whole window. In order to draw a point, you just do draw list, because what this really is over here, it's a structure, okay? And we can actually access this structure using the point access operator indirectly by doing this. And we can, you have now so many options. You have add circle, you add the rect fill, so basically fill the rectangle. You have so many options now. Now I can just do add line. Inside line, you see it will take two variables, and also it will also take a color and a thickness. So let's first create the vec2 variables, which will hold our points. So this will be the initial point. This. Why not? And now we're going to add a line. We're just going to write p1 for the initial point, p2 for our ending point. Next, it's going to be the color, so im_color 32. Oh, I see what's going on here. It's called 32. Sorry, I'm a little bit rusty. And now we can write the color. In this case, it isn't like OpenGL where you are limited from -1 float to, no, from 0 float to 1 float. Now thickness, let's put it to 10 float for good practice. Now, as you can see, it works. So you have the menu here. You can collapse it, you can move it around. It's really smooth. Just my computer is a little bit laggy right now. Checkbox works. Each time you uncheck it, that variable goes to false, true. So you can basically bind things here. You can really, there's no limit in what you can do. All right. I mean, there is maybe if you want to work in 3D, but once again, we're running OpenGL, so that shouldn't be a problem. I hope you guys enjoyed this video and you learned something new, and maybe you got interested into learning on how to use this API, which is magnificent. And I hope I'll make more videos in the future. Thank you. Have a good one.